This tutorial summarizes the key points or the big ideas for the linear relations strand in the grade 9 applied course in Ontario, Canada. So first of all, a linear relation is a relation where the two variables are related by a multiplying factor, or it could be dividing, but we'll always write as multiplying, because since you can even write multiplying by a fraction as something that was divided, and that's called a direct variation. Or there's a multiplying factor plus, or you're adding or subtracting some fixed value, and that's called a partial variation. Now, linear relations have first differences that are always all the same for that entire relation. Now, you can have a different one that those are different than the first one, but they're all the same themselves. And we'll take a look at that through some of the examples. So first of all, example 1, Holly takes a taxi to the airport. She's charged a fixed amount of $5, plus on top of that she is charged 25 cents per kilometer, or $0.25 per kilometer. What equation relates total cost C in dollars to the distance traveled, and we'll call that D. So here, we're going to make up a little chart here. And in the chart, I'm going to use distances 0, 1, 2, 3, 4 kilometers. Of course, it could be a further distance than that, but we're just trying to get the equation, so we don't need to have that long a table. So I'm just going to use the distances from 0 kilometers to 4 kilometers, and we'll calculate the costs. Now, she's being charged 25 cents per kilometer. So here's my first expression to figure out what that cost would be. So if she's not gone any distance, if the taxi cab is just shown up at her door, then we would multiply the $0.25 or 25 cents per kilometer by 0 kilometers, because she hasn't driven anywhere yet, and add the 5. Now this is 0, so 0 plus 5 would be 5. So we'll put the 5 right here, $5 right there. So and that's the the cost the taxi cab would want just to drive to your door, or to Holly's door. So for the second one, she's now driven a kilometer in the taxi cab, so we would multiply the 25 cents by 1 kilometer and add 5. Now 0.25 times 1 is 0.25, so if we add that to $5, we would get $5.25, or $5.25. We'll put that here. So for the next one, we've gone 2 kilometers, so 25 cents times 2 would be 50 cents, added to the $5 is $5.50, and so we'll put $5.50 here. So the next one, she's now gone 3 kilometers, so 3 times 25 cents, plus 5, so this would be 75 cents, added to the 5 is $5.75, or $5.75. Put that right there. And the last one, the table, we're multiplying the 25 cents by 4 and adding 5. And so that's $1 plus $5, $6. So to go for a $4 or so 4 kilometer cab ride would be $6. Now, notice in each case, this is the distance that's being multiplied by the 0.25. So the equation is the cost, C, equals 0.25 times the distance plus 5. So notice that the 5 here, that fixed amount, is just being added on every time. It's not multiplied by the number of kilometers. It's just a constant fixed amount. So the equation would be C equals 0.25D plus 5. Again, the 0.25 is multiplied by each of the distances. So that's the equation that relates the total cost to the distance traveled. In example number 2, a charity has raised some money through fundraising and now must pay out $500 in prize money for each of 10 weeks. The account begins with $5,000, so we're going to pay the prize money out of this $5,000 account. So if M represents the money in the account in dollars and W the number of weeks that they're paying it out, which of the following is an equation that connects the amount of money in the account to the number of weeks paying out the prize money? So I've written this as multiple choice. So here's the 4 different possibilities. You see a lot of questions on EQAO like this. Very similar table to the last one. So let's just take a look at some calculations here. So at the beginning, we would use 0 to represent the number of weeks that have passed. So if no money has been paid out, this calculation gives you how much money the account starts with. So the amount of money is $5,000 minus, and so this will be always the amount that's been paid out. So if none of the $500 isn't paid out, that's why the $500 is multiplied by 0, because it hasn't been paid out yet. So this would be 0. So 5,000 minus 0 would be 5,000. And so we put a 5,000 right here. If you ever have a table that the independent variable over here is 0, then this should always be the fixed amount. And if it's a direct variation, then it actually would be 0, because direct variations always have 0. 0 is one of the points. So after 1 week, the amount of money is 5,000 minus 500 times 1. So 1 week, 500 times $500 has been paid out. So 500 from 5,000 is 4,500. So we put 4,500 here. After 2 weeks, it would be 5,000 minus 500 times 2. That's 1,000. So 1,000 subtracted from 5,000 would be 4,000. And so we'll put 4,000 here. For the third week, 500 gets multiplied by 3 because they've paid out the 500 3 times. That's 1,500 from 5,000 is 3,500, so we'll put 3,500 here. And same idea for the fourth one. 4 times now they've paid 500 out, so that's 2,000 off of 5,000 is $3,000. So that's the last amount. Now notice that this number here is the number of weeks. 0 week, 1 week, 2 week, 3, 4 weeks. So the equation is going to be 5,000 minus 500 times W. W represents the number of weeks. And so this is the correct equation here. M equals 5,000 minus 500 times W. So that's the correct one. And before we go on to another example, I want to point out that there's 2 ways to write this, well, 2 normal ways to write this. Some people would actually write the negative 500 term there and the 5,000 on the end. So I just want to point out that this is another way to write the same relation. You could write M equals, and you could write the negative 500W first. Now the 5,000 is positive, so plus $5,000. So that is exactly the same thing. Notice that this sign belongs to the 500. That's why there's a minus 500W there. And the 5,000 is positive because they started with $5,000. That's why it's plus 5,000 on the end. Example number 3. Amy has decided to subscribe to a new online movie/TV show streaming service called Show Me. Show Me charges $3 per month plus 40 cents for every movie or TV show that you watch. And it says you're asked to find an equation that relates total cost C in dollars for a month's programming to the number of movies and or TV shows, and we'll call that N. N is the number that you watch. And this is the way that all the EQAO questions for linear relations are always structured. You're given 2 variables. You define what they are. C represents cost, the total cost, and it's in dollars as opposed to like cents, or if you're in Britain, pounds or something like that. And then the other variable often doesn't have units. N is just the number of shows, so it's a count. Now in the question, you're told Show Me charges $3 per month. So that's the fixed cost. So this is definitely a partial variation because there's a fixed amount or an initial amount. And you're told that they're being charged plus 40 cents, $0.40 per movie or TV show. So that's the rate that you're being charged per show. Rate means the amount you're charged per something. So for every show, every TV show, every movie you watch, you're being charged 40 cents. So if I want to calculate the cost of the first several shows that are watched, so for example, if you didn't watch any shows the whole month, okay, and you still want to keep the service, then we would go $3 plus 0.40 times 0 because you hadn't watched anything. Now, of course, this is 0, so the cost would just be $3. That's all that they would charge you. If you watched one show the entire month, then the 1 gets multiplied by the 40 cents, so that's 40 cents. Added to the $3 is $3.40. For the second one, the next one, well, I guess it's the third calculation, but it's 2 shows. So we would multiply the 2 shows by the 40 cents. So that's 80 cents. Added to $3 is $3.80. And I'm going to do one more. So if I watch 3 shows the entire month, I know that's not a lot, but if you did. 3 times 0.40 is $1.20, plus 3 would be $4.20. So that's the calculation for 0, 1, 2, or 3 shows or movies. So the equation, see, this is actually the n number here, the number of shows or movies that are being watched. So it's $3 plus 0.40 times the n. Now, a couple things. I did this in the last one. I'll do the same thing here. It doesn't matter whether I do the 3 first and then add to that the 0.40 times 2 or the 0.40 times 2 plus the $3. See, this is still 80 cents. For adding to $3 is $3.80. And same thing for the next one. I could multiply the 3 by the 0.40 first. That's still $1.20. Added to $3 is $4.20. So it doesn't matter if you do the multiplying by the 0.40 first or put the $3 first. It really doesn't matter. So this equation could be written also with the 0.40 n term first plus the $3. And in fact, you might even see it simplified like this. You don't really have to have this 0 here because it's on the end, and the same with these. We could simplify this as just 0.4n because 0.4 is the same as 0.40 and 3 is the same as 3.00. The only reason I'm writing it like that is because it's money, but this would mean exactly the same thing. Example number 4. The graph below shows information about the linear relationship between the cost of a day at a local fair and the number of rides enjoyed. What equation relates the total cost to the number of rides purchased? Now, in this example, we're going to take a look at the example in a moment. Notice that I didn't put in the example defining what the variables were. So if that's the case, then you should do it yourself. So you're clearly stating that these are my variables, this is what they represent, this is the units for them. So I'm going to let C represent the cost in dollars, and R the number of rides taken. So C is the total cost, and R is how many rides were taken at the fair. So let's join these 2 points. So 2, notice, actually it's a good idea to look at the units here. So 1, 2, 3, 4, each of these blocks is 1 ride. Okay, 8 rides, 9 rides. And on the vertical axis, notice there's a break in the graph. So, and from 10 to 15, it goes by, there's 5 blocks there. So 10, 11, 12, 13, 14, 15. So vertically, each of these blocks is also $1. Okay, so the scale is 1 on each axis. So always check that because if you don't, sometimes the scale might be 2 or 5 or 10 or 20, and if it's different than 2 axes, that really matters in the rate calculation. So I connected the 2 points together because I'm going to calculate the rate. Okay, and remember, rate is rise over run. So we're going to take these 2 points. I'm going to draw a horizontal line here and the vertical line up here to make a right triangle. And so across the bottom here, this is 4. So if I start here, 1, 2, 3, 4. So that's 4 rides. And vertically from here to here is 6. And actually it'd be $6. I didn't put the units here. 1, 2, 3, 4, 5, 6. But it actually would be $6. So let's put a dollar symbol there. So for my rate calculation, remember it's rise over run. This is the rise, this is the run, so 6 divided by 4. And 6 divided by 4 is 1.5. Now, it helps you to understand what's going on if you write the units. I made a point of writing the dollars here. So this 1.5, and this is dollars, this is the number of rides. So that would actually be $1.50 per ride. That's what that 1.5 represents. You're being charged $1.50 for every ride you take. Now, if we extend the line down here, notice it's intersecting the cost axis or the vertical axis. I actually can't call it the y-axis because it's a C here. It's actually the C-axis at 10. That 10 is the fixed cost. Okay, so that's one way from a graph to find out what the fixed cost is. Now you do have to make sure you draw it very accurately. I mean, I can't, like draw this on an angle down here. Oh, it looks like it's 9 or something like that. You do have to be very precise when you draw it. And one thing to kind of notice is, see, it's Okay, it's going down $1.50, and then it's going down another $1.50. So it's, that's a way you can check to see if it's going down the same amount. The 1.5 is the rate, and again, this is a horizontal change of 1. So if I go to the left 1, I'm going down 1.5. Left 1, I'm going down 1.5. That also gets me exactly to 10. So the equation would look like this. Equation would be the cost is 1.50 times the number of rides plus 10. And again, you could drop the 0 and write it as 1.5R. You can't drop the 0 into 10 because that would change it to a 1. Okay, so that's not okay. But that would be the equation that would relate the cost to the number of rides taken. Example number 5. The Fornells rent 2 motor scooters one day while on vacation. The cost to rent them for several hours is given in the table. Find the equation that relates the total cost C in dollars to the number of hours, so N is the number of hours, they rent the scooters. So in this case, we're given the table. So 0 hours rented, it's $20. 1 hour is $24. 2, it's $28. 3, it's $32, etc. So we're going to calculate what are called the first differences here. So from 20 to 24, it goes up by 4. From 24 to 28, it goes up by 4. And if you happen to be doing these with a calculator, you always subtract the bottom number minus the one above it. So for example, it's 32 minus 28 to get the next one. Okay. If you do 28 minus 32, that actually gives you negative 4, because if you do 28 minus 32, you're talking about the change going from 32 down to 28. That's why that would be negative. So always put the bottom number minus the one above it. So the next one, okay, so here comes my next one. So the next one for the 32 to 36, we would do 36 minus 32 is positive 4. So these are all the same, so it's a linear relation. Okay, definitely. Now, so the cost, so here's a similar cost calculation to it from the previous examples. So for example, if we have 3 hours here, the 4 is actually the rate. It's how much being charged per hour. So for example, if I take 4 and multiply it by the 3 hours, okay, that's why I'm doing 4 times 3 here, plus 20, that gives me 32. Now, where do I get the 20 from? Well, the 20 is the fixed cost. If you have a table that has a 0 in this column, in independent column, see, the number of hours is the independent variable, because I would decide, okay, I want to rent it for 4 hours, for example, or I want to rent it for 7 hours. So the person would choose how long they want to rent it for, or the business would say, well, how long do you rent it for? 6 hours? Okay, so this is going to be the cost. See, the independent variable is what you decide on. The cost depends on what the time that it was rented. So the value, the cost associated with 0 hours is a fixed cost. That's why we're adding 20 here. So 3 times the 4 is 12, plus that 20 gives the 32. So in each case, these times are being multiplied by the 4, and then that fixed amount's being added. So these values over here will always be the cost per hour. Now, as long as this is going up by 1, if this went 0 hours, 2 hours, 4, 6, 8, then I would have to divide these by 2. See, this actually is rise over run. If these go up by 1, I don't bother often put the ones. You can, it's not wrong, but the rate is always this number divided by the changes here, which in this case are 1. 4 divided by 1 is still 4. So that's the cost per hour. This is the cost per hour right here in the formula. So the equation would look like this. The cost is 4 times the number of hours plus 20. And from the question, that should make sense, because if you're being charged $4 for every hour, then we multiply the number of hours by 4, and that's what the business would do to figure out how much they're going to charge you, and then add on the fixed amount, the $20. Example number 6. Emily has $380 in her savings account. She deposits $40 per week in her savings account from her part-time job, so she's trying to save some money. Denise starts with $100 less than Emily, but deposits an extra $20 each week. Which of the following represents the amount of money A, in dollars in Denise's account after n weeks. So n is the time measured in weeks, and A is the number of dollars. So again, this is a multiple choice similar to one of the previous ones. So we have to pick out which one of these is the correct equation that relates to the amount in the account to the number of weeks. So one way to organize this is to make a table for how much each of them has at the beginning and how much they're saving each week. So in the question, you're told that Emily starts with $380 and she's depositing $40 every week. So that's her rate. Again, the rate is how much is changing over time. She's depositing $40 per week. Now, Denise starts with $100 less. So if Emily started with $380, Denise would start with $280, $100 less. And it says that Denise is depositing an extra $20 each week. So 20 higher than 40 would be 60. So that's her fixed amount. That's how much she's depositing per week. So we want to do a few calculations to figure out how much she has after 1 week, after 2 weeks, etc. So she starts with $280, and after a single week, she adds on $60 once. So 60 times 1 would be 60, added to 280 would be 340. If we want to figure out how much she has after a second week, then the 60 is multiplied by 2 because 2 times she's deposited $60. So that's 120, added to 280 is 400. Now, this calculation is similar to a couple of the previous examples. If you wanted to, we could write it in a different form. So, and we'll get into that in a moment. So the way I've written it here, it's 280 plus 60 times the number of weeks. So it would be $280 plus 60 times n. N representing the number of weeks, A the amount in her account. So here's the alternate way to write it I was just mentioning. If instead of writing the 280 first, I could write it second and do the 60 times 2 first. See, that's still 120, added 280 is 400. So instead of writing 280, A equals 280 plus 60n, you also could write the amount, A, is 60n plus 280. Those are the same equation. And if you look over here at our multiple choice, that's this one right here. A equals 60n plus 280, so D would be the correct answer there. Question number 7. A glider approaches an airstrip. Its altitude is shown by 2 points on the graph. Find the equation that relates the altitude to the time. So here it's, and again, look at the scale. Okay, so 1 minute, 2 minutes, 3 minutes, 4. So every block here is 1, but it's not on the vertical axis. So 1, 2, 3, 4, 5. Now, if you want to figure out how much each one of those blocks is, then take your calculator and see I have 1,000. 5 blocks makes 1,000. So 1,000 divided by 5 means that everyone is 200. So 200, 400, 600, 800, 1,000, 1,200, 1,400, 1,600, 1,800, that's 2,000. Okay, so every block on the vertical axis, on the altitude axis, is 200 meters. So now notice in the question, it did not tell me what to use for variables or what the units were, so you should do that. So this is often called a let statement. So we're going to let A represent the altitude in meters and T the number of minutes, or the time in minutes. And so I'm going to connect these together and we're going to calculate the rate. Obviously it's going down because here it's higher than it is 3 minutes later. And so we're going to drop a line down to cross to calculate the rate. So remember, rate is rise over run. Now, the change from here to here is 1,200 meters, and it's down. You can count 200, 400, 600, 800, 1,000, 1,200. So from here to here, it's gone down 1,200. Make sure you have that negative with it because it's going down. And this would be 1, 2, 3 minutes. So my rate is negative 1,200 over 3. And again, it's a good idea to write the units here. So this is meters, and this is minutes, and that'll help you to understand what this number represents. So when we divide negative 1,200 by 3, we get negative 400. and that the units for that would be meters per minute. Meters per minute. So that means how much the glider is going down. It's losing 400 meters of altitude every minute. Now, I've just extended the line up here, and we can see that the vertical axis intercept, the altitude axis, is 2200. Remember, each block is 200, so if that's 2000, that would be 2200. So we can use that to help us get the equation. So for example, this point right here, to go from 2200 to there 1 minute later, notice it's gone down 400, so 200, 400. So that point is the original 2200 meters minus, in 1 minute they've gone down 400 meters. 2200 minus 400 is 1800. This point right here, after another minute, they've gone down another 400. So the 2200 is the original amount at the beginning of the graph, and minus, then they've gone down 800 because twice they've gone down 400. So that gives us 1400, and that would be 1400 right there. So that's the structure of the equation. This is the time right here, t, and this is the initial amount. So the equation would look like this. This is the initial amount minus 400 times the number of minutes they're flying for. And you'll see sometimes it'll be written in this order. This negative 400t term first plus the 2200. So those two mean exactly the same thing. I'm just running in a different order. Not much different than if I had numbers. See up here, this calculation, 2200 minus 800 is done to get that 1400. And it would be equivalent to write the negative 800 first plus 2200. That still works out to exactly 1400. So those are exactly the same thing. So these are both correct ways to write the same equation. Second last example, number 8. Todd starts walking from home to the corner store. So this is the beginning of his journey. This is the end. He's at the corner store for a few minutes and then goes back home. So this is the walking to the store. He's going away from his house. Okay, and then he stops at the store for a few minutes and then he goes back home. Okay, that's his whole journey. There's 3 parts to it. And A is asked, at what rate does he walk to the store? Now remember, rate is rise over run. And in this case, from here to here, this rise is actually a distance. Okay, so instead of calling it rise, I'm going to call it distance because that's what it actually is. And horizontally, this is time on the bottom axis. So the rise over run is the same as distance over time here. So the distance he actually walks from here to here is 800 meters. Notice every block here would be 100, 200, 300, 400. So this would actually be 800 because it's 700, 800, it's 200 above the 600. So that rise is 800 meters in, okay, that's 5, 6, 7, 8 minutes. So 800 meters divided by 8 minutes, if we divide 800 by 8, you get 100. So he's walking at a rate of 100 meters every minute. So that's how the rate, or how fast he's walking from his home to the store. How long was Todd at the store? Well, when he's at the store, he's not getting any further away from home or any closer to home. So his distance from home is staying constant. See it from all the way along here to here, he's 800 meters from home. So 1, 2, 3 minutes, that's how long he was at the store. So then he leaves to go back home. So this is his trip back home. So it says, how does his trip from the corner store back to his house differ from the first part when he walks to the store? So you're asked, how is this trip here different than this one? Well, let's calculate the rate. You can see that it's steeper, and that means something. So if I want to calculate the rate again, it's the same 800 meters, but from here to here, instead of 8 minutes, it's only 4. So 1, 2, 3, 4 minutes. So 800 meters divided by 4 minutes is 200 meters per minute. So he's going quicker. He walked to the store at a rate of 100 meters every minute, and he goes back home at a rate of 200 meters every minute. So he's going twice as fast. So it's likely he probably ran home from the store, or he walked very quickly. Maybe he was getting close to his curfew time and needed to get back. Okay, so but he was, for some reason, he went back home quicker than he went to the store. Example number 9. An online retailer charges for shipping according to the table below. Graph the data in the table on the grid provided, and then you're also asked to write an equation that relates total cost C in dollars to the number of items N that are shipped. So C represents the total cost, and N is how many items are being shipped. So notice there, I don't have a scale on this vertical axis, and sometimes on the EQAO questions you'll be asked to decide on a scale and use it. So if you look at what's being labeled on this cost axis, 14, 22, 42, I need to be able to get as high as, in the 40s or 50 or so. So if you look here, I could go 10, 20, 30, 40, and that would be good enough. But it actually give me quite a bit of room above. So it's best to try to use as much of the graph as you can. So instead I'm going to use 5. Every block's 5. So this would be 5, 10, 15, 20. So that's why I used the scale that I did. So, and I didn't bother to put all the 5s. That's 10s. This would be 15. That'd be 20, 25, 30, etc. And so I can get past 40 easily. That would actually be 60 right there. So let's plot the points. So 2 items shipped is $14. So 2 items shipped would be $14. Put a dot right there. See, that would be 15, so just slightly below it. And 4 items shipped is 22. So see, this would be 20, that'd be 25, so 22.50 would be right in the middle, so it's barely below the midpoint there. And then 9 items being shipped is $42. So there's the last point, and we can draw a line between them. And it's certainly a line, so this is a linear relationship. So let's calculate the rate, which is how much they're being charged per item, and I'll explain why it's that. So if you look at the differences, and I'm only going to go between 2 and 4 and then 14 and 22, this difference right here is 8. And again, you have to make sure that you're subtracting those numbers in the right order. If you went 14 minus 22, that's negative 8. That's actually to change from 22 down to 14. If I wanted to change from 14 up to 22, then you should always type that second number first. 14 subtracted from 22 is 8. See, that's an increase of 8 if you go from $14 to $22. And from 2 items to 4 items, that's a change of 2 items, so that's 2. So remember, rate is rise over run. And this 8 would represent $8. So $8 is the rise, and 2 is actually 2 items. There's 2 things being shipped. And it's important to write those units so you understand what the rate represents. 8 divided by 2 is 4. So that rate represents that you're being charged $4 per item that's being shipped. So let's write out the equation here. And to get the equation, you need the fixed amount. And if you look at where the line goes through the vertical axis, it looks like the fixed amount is probably around, see, it's a little over 5. It's probably around $6. 6, 7, okay, probably closer to 6. And a way you could actually check that from the chart, the graph, is this. You could use the fact that the rate is $4, or it's going up 8 for every 2. See, if I go from 2 back down, this would actually be 0 here. I'm going to put a 0 there. This would be 0. And do the same thing over here. See, so that would be a change of 8 as well. Now we're kind of going up the table, so this number would be 8 less than 14. So if we do that, 14 minus 8 to go back up the table, then this number should be a 6. So you can expand the table a bit to find what the fixed amount is too, if you can't read it from the graph, or you're not 100% sure what it is from the graph. So we went down 2 more items to get to 0, and so the fixed cost is $6. So the equation would be the cost is $4 times the number of items. Remember, the rate was 4 plus 6, 6 being the fixed amount read from here or from the graph. And that's the end of the tutorial.